In this presentation, we're going to discuss how graph coloring techniques can be used to determine the minimum number of instructors required to teach a given cohort of students. First, we're going to introduce the context of the problem. Then we're going to illustrate candidate schedules and their corresponding graphs. And then finally, we're going to illustrate proper colorings of those graphs and discuss the implications of the results. For some context for this problem, this set of examples is loosely based on my experience as an instructor at the Naval Nuclear Power School. At that school, incoming students are scheduled to take 3 classes throughout the day. They are heat transfer, math, and physics. These student cohorts are broken into sections, and each section attends class in separate classrooms throughout the day. Instructors are qualified to teach one of these 3 subjects. Instructors can teach multiple sections if the classes are not occurring at the same time. Let's take a look at how this problem is formulated. The school day is broken down into 6 one-hour class periods. We're going to assume that each subject is taught for 2 consecutive hours, which allows us to break up the school day for each section into 3 two-hour blocks. For simplicity, we're only going to consider 2 sections, but these methods can be expanded to account for larger numbers of sections. The basic schedule on the left can be represented as a graph, which we show on the right, when you consider each 2-hour block as a vertex, and then the edges connecting vertices that correspond to blocks that cannot be taught by the same instructor. Since this is just a basic schedule that does not include which subjects are taught at which times, the only edges that are in this initial graph correspond to 2-hour blocks that are occurring at the same time. We can create a coloring for this basic schedule to give us an idea of the minimum number of instructors that are required to teach these 2 classes. Unsurprisingly, in this case, we have a bipartite graph, so only 2 colors are required to color the graph properly, and this means that we only need 2 instructors, one instructor to teach all classes for section A, and a separate instructor to teach all classes for section B. The problem becomes much more complex when we consider which subjects we're going to be taught at which times, and considering that instructors are only qualified to teach one subject. Here we have the worst possible scenario where section A and section B have the same class schedule. This results in a fully connected graph shown on the right. Since the graph is fully connected, the only possible coloring is to have each vertex with a distinct color. This means that 6 instructors would be required to teach these 2 sections with this schedule. The second schedule is organized in a way such that an instructor can teach a 2-hour block to section A as well as a separate 2-hour block to section B. We can see in the graph on the right that not every edge is included, so we have the possibility of coloring this graph with fewer than 6 colors. We can see that schedule number 2 can be colored with 3 colors. We know that this is the best possible configuration for the schedule because we have 3 separate subjects, and we need an instructor qualified in each of those subjects to teach each section. I hope you've enjoyed this video. Thank you for watching.